Hello students, welcome to this week's brain exercise. Right, this week we're going to solve some problems involving sets. And we will also be making thinking visible by using Mr. Poya's 4 steps problem solving to solve question 14. Right, so please stay till the end of the video, right? And let's go nail all the questions from exercise 3.1. Alright, let's start with something rather simple. So for question 1b and 2b, we're asked to simplify the expressions involving sets. So for 1b, what we need to do is to recognize what are the like sets. Right, so just to do a recap, a square root b is like terms, is a like term with c square root b, where both a and c can be any real numbers. Right. If you have a square root bc, all right, this is not a like term with the square root b. Okay, right, so basically you must make sure that what is in the radical sign, okay, must be the same. If it's square root b, the other guy also must be square root b, but the number in front of your radical signs can be any real numbers. All right, so having explained that, you would have observed that this guy here, it's like term with this guy. It's just nice. Just place it so nicely for you. Right, so that is 2 square root 3 minus 1 square root 3. Okay, 1 square root 3. If you want, you can just factorize your square root 3 out. And of course, 2 square root 2, your square root 2, it's not a like terms with square root 3. So that we'll just leave it alone. And then 2 minus 1 will just give you 1. 1 times square root 3 will be just square root 3. Okay, so question 1b, it's rather basic. But it's very important to understand the basic before we can go on to do something more difficult. Right, so for 2b, right, if you were to recall, this one of these algebraic identities. This one is very important. Okay, we'll be using a lot of these. We will also be using this in polynomials and things like that. So we're going to use that to expand this guy here. Right, so let's do the substitution. So your a, you can substitute a for the substitute the values to be 2. Then so that will give me bracket 2 squared, and then 2 times 2, and then the values to substitute for the letter b will be square root 3, then plus bracket square root 3 close bracket squared. Right, this is easy. 2 squared will just give you 4. This one you just multiply the integers first. 2 times 2, then times square root 3. So maybe you have to do some calculation inside your head. So that will give you 4 square root 3. And of course, we have dealt with this before. Okay, this one means that if you have a square root a times a square root a more than 0, you will just end up with getting an a. So square root 3 times square root 3 will just give you a 3. And then you can group these two numbers together, 2 integers together, that gives you 7 plus 4 square root 3. And that's how you do it. Okay? All right, let's come to question 3c. So we have done some simplifications of sets. What we need to do now is we need to know how to rationalize the denominator. Okay, if you look at the denominator, it doesn't look pretty, right? It's not a rational number. So usually we would want the denominator to be a rational number. So what we need to do here is to call out. Yes, we need to call out. Call out who? Call out the conjugate sets of 2 square root 5 minus 4. Right, so what's the conjugate sets of let me write it out. Conjugate sets. Alright, so what's the conjugate sets of 2 square root 5 minus 4? Ding, 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 ding. Yes, it's 2 square root 5 plus 4. Right, so what we're going to do is we're just going to multiply it with 2 square root 5 plus 4 at the numerator, also at the denominator. And then this will give me 12 bracket 2 square root 5 plus 4. Right, and the bottom one, if you were to recall your two conjugate sets, you can actually, what do you call that? Liken it to be A minus B and then A plus B, right? So this is another algebraic identities that it's very, very commonly used. That will give you A squared minus B squared, right? So therefore, that will give you bracket 2 square root 5 close bracket squared minus open bracket 4 squared. Right, so the numerator, you can simplify it into 12 times 2 square root 5. So that will give you 12 times 2 is 24. 24 times square root 5 will be just 24 square root 5. And then take 12 times 4, that will give you 48. And then the denominator, you will end up getting a rational number. So just go ahead and use a calculator to work this out. Seriously, I really mean it. Use a calculator to work it out. So you would have, as usual, my calculator is not with me. Okay, never mind. I'll just have to do mentally. Alright, let's give you 4. Okay, then the next step is you can just factorize. If you look at this 48, sorry, that's 24. 24 and 48, you can actually factorize 4 out. Right, and then your 4 divides by 4 gives you 1. And here we are, we get 6 square root 5 plus 12. Right. Okay. Alright, let's come to 6D. 6D is slightly more challenging. Why more challenging? Because the number is given, it's, what do you call that? Are bigger. And then they are not in simplified form. Right, and also if you were to observe carefully, the numerators, it's involving sets, denominators also involving sets. So before we go on to rationalize it, okay, let's try to simplify it first. Simplify the sets. It's also good that we actually practiced simplifications of sets. Some of you may have already forgotten how to do that. So to simplify sets, right, we always try to find the biggest square number you can think of, square number of perfect square. So like for example, 18, right? Right. It can be 2 times 9, right? It can also be 3 times 6. But I would choose 2 times 9 because I need this guy. I need 9 because 9 is a perfect square. Okay, because square root of 9 will give me 3. Okay, so that's the reason why even though I can express 18 as 3 times 6, I would choose 2 times 9 instead. So this is 2 times 9. And then for 12, okay, you can have 2 times 6, but 2 times 6, there is no square number there. So I would rather use 3 times 4, right? Because 4 is a square number. Square number is also a perfect square. It means the same thing. Okay, so 50. 50 will be 25 times 2. 48. 48 will be what? Of course, you can use 4 times 12 lah, but again, okay, 48 is a bit tricky, right? Because 4 is a perfect square, right? So why wouldn't I want to use 4 times 12? Because I can actually have a bigger square number than 4, which is 16. 16 times 3 is 48. So I would want to use one that have a bigger square number. Okay, so I would use 16 times 3. Alright, so let's simplify further. So we will break it up into square root 2 times square root 9 minus square root 3 times square root 4. So this one involves more steps. So you need to have a calm mind and lots of patience. Alright, so that will give us 3 square root 2, because square root 2 times square root 9. Square root 9 is 3. So square root 2 times 3 will just be 3 square root 2. And then square root 4 is 2, so you just put the integers in front of your surds. 5 square root 2 minus 4 square root 3. Okay, so the next step is we have to call out our conjugate surds. Okay, we have to call out the conjugate surds for this guy here. Where are you? What is it? Of course, it will be just 5 square root 2 plus 4 square root 3. That is our conjugate surds. Alright. Okay, so the numerator will look like this. And the denominator will be this. Okay? Right. So I'm going to use distributive law to work out the numerator. So 3 square root 2 multiplied by 5 square root 2 plus 4 square root 3. Then negative 2. Okay, I need to write it smaller a bit. Over, okay, that will be our a squared. Oh, okay, I already have it there. So we can just use a calculator to work this out. Okay. Right, so using a calculator to work this out, there will be bracket 5 square root 2 close bracket squared minus open bracket 4 square root 3 close bracket squared. That gives us 2. Okay, let's simplify your numerator. Okay, so you will have to do some mental calculations inside your head now. So, or you can just use your, no, you can, okay, just mental. So 3 times, okay, work out your 2 square root 2 times square root 2 first. So square root 2 times square root 2 will give you 2, right? So that will be 2 times 5 times 3. That gives you 30. And then this guy and this guy will give you, work out the number first, the integer first, positive. So 3 times 4 is 12. Then square root 2, okay, square root 2 times square root 3. This one you have to apply this rule, where both a and b are more than 0, so that gives you square root 6. Okay, and then the next one is negative 2 times 5, so that gives you negative 10. And then square root 3 times square root 2 gives you square root 6. So can you see what I'm doing? I'm actually doing step by step. Just work out the sign first, then the number, and then the surds. Alright, then go back to here again. So that will be negative 2 times positive 4, so negative 8. Square root 3 times square root 3, that gives you 3 over 2. Okay, so that simplify further. So that will be 30 minus 24. Give me 6. Alright, so these two guys, 12 square root 6 minus 10 square root 6, they are like terms. So give me 2 square root 6 over 2. And of course, I can factorize 2 out. And then 2 and the 2 can go off. So the answer we will be getting will be just 3 plus square root 6. Alright, so it appeared complicated, right? So to do such complicated questions is that, first of all, you must observe a calmness of your mind, okay? Be patient, alright? And then sometimes you may just, if you're at home doing it, when nobody is around, you can just practice what I've done. Just talk it out, okay? Talk it out, but of course in exam you can't do that. Okay. Right, let's look at question 7a. So you can see that there is a variations of questions, right? From the simplest one, asking you to simplify surds, and then we progress to multiplications of surds, where you have to use your algebraic identity, and then go on to rationalize it, right? So the next question, it's accumulations, you know, like in this case here, this guy you need to simplify it. This one nothing much you can do, and this guy you will have to rationalize it. Okay, so it's involved all that you have learned, put them together to solve this 7a. Right, so for the 4 square root 12, we're going to write 12 as 4 times 3. Now this guy 2/3 square root 3, we're not going to not yet, just leave it alone first. And then for this, we're going to rationalize it. So we just multiplied with square root 3 at the numerator and square root 3 at the denominator. Okay, why you want to do that? Some of you may be asking me, because do you recall that to make square root a rational number, you just multiply with another square root a, and then you get your a, which is a rational number. Okay, that's the reason we want to make this guy a rational number. So of course, when you have to do it when you multiply, you have to multiply at the denominator and also at the numerator lah. Okay, right, so let's go on. So that will give you 4 times square root 4 times square root 3. That will give us 18 square root 3 and 3 square root 3 times square root 3 give you 3. Okay, let's simplify further. Square root 4 will be 2. And 18 divided by 3 will give you 6. Alright, so you'll see that there's a common factor, square root 3. You can just factorize it. So you end up getting 4 times 2, which is 8, minus 2/3 minus 6. And you can easily just use your calculator to work this guy out, which is 8 minus 2 over 3, 2/3 minus 6. And that gives you 4/3. So we're going to write it as 4/3 and square root 3. Okay, usually we'll write the number in front of the surds for better presentation. All right, okay, let's look at the next question. Okay, what do you think you would want to do it first before we apply the rules of surds? Actually, there are 2 ways of solving these questions. But I think, yeah, whichever ways, I think it's still best to expand this guy also. Okay, maybe we try this way first. Okay, so the first way I'm going to do is just to expand your denominator, and that you can just use a minus b squared here. Okay, and this guy you can just use a plus b squared, right? Okay, so let's do it. So that will give me 1 over okay, actually you can just expand it somewhere first, you know what I mean, and then you just put it back to the denominator lah. I think it's neater that way. So that will give me 2 square root 7 times 2 square root 7. If you cannot manage it, you can just write it out. Or you can use your calculator. You will get the rational number. Because when you square a square root, you will get a rational number. So this will give me 2 times 2, 4. 4 times 3, 12. This one you can't use calculator because you will get a lot of decimal places. Okay, 3 squared will be 9. So 28 plus 9, that will give you 37. Then what happens if it's 2 square root 7 plus 3? Right, so it will give you Instead of minus, it's plus here, right? Okay, plus. So that means your answer will be 37 plus 12 square root 7. You don't really actually have to work this guy out. Okay, so having done that, we can just plug it back into our denominator. So that will be 37 minus 12 minus 1 over 37 plus. Alright, so if you were to observe it very carefully, I think a lot of you would just want to combine them into one fraction, right? Yes, so if you're going to combine them into one fraction, can you see this guy is this guy here is can be likened to bracket a minus b, and this one is your a plus b. So if you're going to put them together, you would get what? Put them together. That means you multiply both of them together, right? Multiply them together. Okay? So you would get just your a squared minus b squared, which is bracket 37 squared minus bracket 12 square root 7. Okay, then how about your numerator? Okay, so the numerator will be, you need to take 1 multiply with this folks here. This is basic math, or I think I don't need to explain why lah. And then the other guy multiply with this folks here. Okay, so I need to write a bit smaller. Okay, then I expand it out. So that will give me 37 plus 12 square root 7 minus 37. And watch out for this. That will give you plus 12 square root 7. Alright, so this 37 minus 37 will be gone. So you left 12 square root 7 plus 12 square root 7. That gives you 24 square root 7. And your denominator, just use a calculator to work it out. That will give me 12 times square root 7. 361. Wow. Okay. One thing very good about having a calculator is that it can really lighten. This is not liken, it's lighten your workload. So we're going to do fractions 24 over 361 to see if we can simplify it further. Oh, cannot. So you can't simplify it further. So can't simplify it further, and that's it. That's our answer. Alright, so having done questions that are rather straightforward, you just need to apply the skills that we have learned, like rationalizing it, expanding it, combine into one fraction, things like that. So let's do a question 4 that is slightly more different in the sense that you are asked to do some explanation. So you're given two numbers, square root 3. Okay, given two numbers here. One is square root 3, and one is 2 over square root 3. And then the question says that you're not supposed to use a calculator, meaning you're not going to use a calculator to evaluate square root 3. You can't do that. Let me show you what it means by cannot use calculator. This is, and then 2 over square root 3. And then from there you say that okay, since this guy is more than 1.15, so therefore square root 3. So this is using calculator. Okay, this is using calculator to evaluate your answer. This is exactly what the question does not want you to do. Okay, right, so we cannot use this method. Quickly erase. Cannot. Right, so if you can't do that, then what is the correct way of doing it? That means you need to show the steps. You can still use your calculator to help you, but you just have to show your steps. So basically, square root 3 is just square root 3. You can't do anything. However, the 2 over square root 3, we have learned something earlier on, right? We can actually rationalize it, right? Yeah, you can just rationalize it. So this question basically is just test you on the concepts of rationalization. So that gives you 2/3 square root 3. Alright, then you compare 2/3 square root 3 with square root 3. Square root 3 means 1 square root 3. So obviously 2 times square root 3 is less than. So it just says that since 2 times square root 3 is less than square root 3, because square root 3 is 1 square root 3, right? Correct. So 2 times is less than 1, right? So therefore, we conclude that square root 3 is larger. Yeah. Okay? Right, so in these questions, we're going to apply Poyer's 4-step problem solving approach. You will find that in every exercise, right, we will attempt to use Poyer's 4-step problem solving approach. Hopefully that after doing it many times, the skill would have become part of you, so that even without having to write out the steps, it becomes part of you, that it becomes uh, a way for you to solve any problems, right, effortlessly. Okay, this is what we want to achieve. So what is this problem that we're going to solve today? Yes, right, you're given you've given P and Q such that this P and Q are the two distinct and real roots of equations given, and then one of them is bigger than the other one, and after finding the values for P and Q, we need to express it in surds. And if you look at what you're given, right, this one, it's a rationalized surd already, because the denominator is a rational number. Okay, and m and n are integers, right? So sometimes it is not possible to always be given similar questions. Sometimes you're given questions that you have not seen before, but the concepts are the same. So if that is the case, then how do we actually use the concepts we have learned to apply to solve new problem? That's why we have to practice using this Poyer's 4-step problem solving approach. So step number 1 is to understand the problem. So what is this problem all about? Right, so if you look at it deeper, right, the roots of the equations basically it just refer to the solutions of the equations. So what we are trying to say is that there are actually two solutions of the equations, where we're going to call it, after finding the values for x, which are solutions of the equations, we're going to call them P and call them Q. And of course, the values of P must be greater than Q. After that, we're going to form a fraction, and because if it's a fraction, then the answers given is in surd form, so you may need the concepts of rationalization of surds. Right, so this is understanding the problem. Right, so step number 2 is to think of a plan. So you can draw a diagram, you can use model, guess and check, which most of the time we don't use guess and check here. You can solve part of the equations, or here we're going to restate the problem. Sometimes the problems, the questions, the phrasing could be quite intimidating, right? But actually, if you rephrase it, you will find that it's something very similar that what we have done before. So if you were to restate the problem, actually all we need to do is just to solve the equation. Yes, solve the equation, and the answers you get for x, you just call one of them P and call the other one Q. Right, so how do we go about solving a quadratic equation? Right, so we have learned, so if you go back to your database, there are few methods we have learned. Okay, the cross method, which of course we can't be using here because it involves surds, completing the square, and all quadratic formula. Right, so here we'll be using quadratic formula. You can go ahead and try completing the square. You would get the same answer. All right, so step 3 is carry out the plan. So once you have an idea, usually step 1 and step 2 are more difficult, understanding the problem and thinking of a plan. But once you have the plan ready, you can just carry it out. And of course, the plan here we're going to carry out is to apply quadratic formula to solve the quadratic equation. So before we do that, we need to do some rearrangement. We need to arrange it in the form ax squared plus bx plus c equals 0. Then you write down the values of A, values of B and C. Substitute into your quadratic formula. Simplify it. Okay, so this is here where we need to bring in your the skills of simplifying sets. Okay, you need to bring in the skills of simplifying sets. The two rules, like square root, what are the two rules here? This one, square root AB is equals to square root A times square root B, where both A and B are more than 0. Or if you have square root A over B, you can actually break it up into square root A over square root B. Again, both A and B must be more than 0. Okay, so we're going to simplify square root 20 as square root 4 times square root 5, and square root 8 as square root 4 times square root 2. Okay, right, and this is what you get, and then you factorize your 2 out, and of course the 2 and the 2, you can just cancel them. Okay, we need to erase this because you're actually hiding my answer. Blocking, not hiding, sorry, blocking the answer. So the rules that I mentioned earlier on is this guy, but I think we're not going to use it here. Basically, we're using this check only. All right, so there are two values. Okay, one of them is more than the other. So square root 5 plus square root 2, surely it will be more than square root 5 minus square root 2. So we're going to call square root 5 plus square root 2 as P, and square root 5 minus square root 2 as Q. Right, so what's the next thing we need to do? We need to express it as P over Q. Right, so we're going to call P as square root 5 plus square root 2, Q as square root 5 minus square root 2, put them as fractions. Right, and we need to simplify it, right? So to simplify it, what is the concept involved here? If you look at your denominator, it's actually a cert, and we don't like it to we don't like it. We don't like sets where the denominator it's not a rational number. So here we need to rationalize it, and to rationalize it, I need to write down the conjugate sets for your denominator. The conjugate sets for denominator, which will be square root 5 plus square root 2. Okay, so we're going to multiply it at the numerator denominator. Okay, right, and here you're going to apply your algebraic identities. Okay, and this guy also, you're going to apply your a to minus b gives you a squared minus b squared. So the three algebraic identities are very, very important, really very important. Okay, you have to learn them well. We use them so often here. Often, okay, whatever. All right, so this is what we get at the numerator and also at the denominator. Simplify further. Yes, and we will end up getting 7 plus 2 square root 10 over 3. Right, so that's not all. That's not all, because we need to verify if the answers we get it's valid. Because we don't want to work so hard and finally get the wrong answer, right? So how do we verify it? So that's where we go to step 4. Right, so step 4 is to look back. So the answer we found is reasonable. Why is it reasonable? Because in this question actually is quite a giveaway questions, because they actually in the question exactly you are told the form how your answer should be in. And if you can find your answer in the form m plus n square root 10 over 3, then most of the time you're correct. Just to make sure your m and n are both integers. And in this case here, yes, we managed to find m to be 7, which is an integer. We find n to be 2, also an integer, and we have square root 10, and we have denominator 3. So therefore, our answer is 100% correct. Okay? Right, this is how you solve question 14. Right, let's look at question 19. So if you look at question 19, it may appear to be a bit difficult because what you are given, it's in terms of a variables. It's not number. But if I'm going to just replace your square root a with a number, or with square root 3, let's say, and then replace your square root a plus 1 with, let's say, square root 5, and what you'll be given is just 1 over square root 3, 1 over then square root 3 minus square root 5, right? So if given the questions like this, what do you think, what kind of operations do you think you would carry out to simplify it? Yeah, you would just go ahead to rationalize it, right? So to rationalize it, you would just multiply with the conjugate surd. Here in this case will be square root 3 plus square root 5, right? Just multiply it at the numerator, also at the denominator, right? So this is the concept involved here. So this is exactly what we're going to do. We're just going to multiply this guy here with this conjugate surd, which will be just square root a minus square root a plus 1 over square root a minus square root a plus 1, and that will give us square root a minus square root a plus 1 at the numerator, because you're just multiplying with 1. Then for the denominator, alright, it will become, you will need to use your algebraic identities. Alright, bracket bracket x plus y times bracket x minus y. So that will give you x squared minus y squared, right? So your denominator will come out to be bracket square root a squared minus bracket square root a plus 1 squared, right? So if we simplify further, that will give you a square root a times a give you square root a times square root a gives you a, and likewise for the other one, square root a plus 1 times another square root a plus 1 will just give you this. Alright, so if you simplify further, so it's just a matter of keep simplifying it. You will have a minus 1 that gives you negative 1, right? Alright, then the next step, of course, you will multiply by negative 1 at the numerator, also at the denominator. So you will end up getting negative square root a plus square root a plus 1 over positive 1. And that gives you square root a plus 1 minus square root a, which is what is supposed to show. Right, so just bracket shown. Right, so this question is not exactly that difficult. Right, you just have to apply rationalization skill, okay, to rationalize your left hand side, and do some algebraic manipulations, and then you'll get what you need to show. Right, let's look at 19 part 2. It's a very interesting question. Okay, if you're going to do it like if you're going to rationalize this one, rationalize every one of them, then you realize that it's going to be very tedious. That's why if you look at the questions, right, it says there's this word hence here. It means that we kind of make use of the answer that we have found from 19 part I. Okay, so from 19 part I, we've already managed to show this. So we can actually make use of that information. So how do we, let's analyze what we have found earlier on. That's very important. Okay, you see that this guy here, all right, will become your second term. And then this guy here, the second term will become, okay, don't use red, use a different color, going to see the difference. The second guy will become your first guy, and what separates them, it's a negative sign. So in other words, let's try to express this in the form that we have found earlier on. So the second guy, let's look at the second guy first. The second guy, which is square root 2, will become the first guy, minus, then the first guy will become the second guy, right? And let's keep going. So the second guy, which is square root 3, become your first guy, minus your first guy. Then 1 over square root 3 plus square root 4. Okay, second guy will become your first guy, minus first guy becomes second guy. So you can have another one it's good to have another one so that you can actually see the patterns. So another one we can use will be 1 over square root 5 plus square root 4, sorry, 1 over square root 4 plus square root 5. So square root 5 become the first guy, square root 4 become the second guy. So on and so forth until the last one is 1 over square root 8 plus square root 9. So square root 9 become the first guy, square root 8 become the second guy. Okay, so we need to add all this together, right? That means I need to take this plus this one plus this one. Okay, you add them. So when you add them up, right? You add them up. You will see that you can actually certain what do you call that, numbers can be eliminated. For example, like this one is positive square root 2, right? Positive square root 2, when you different color. Okay, positive square root 2, right? When you add to your negative square root 2, can you see that these two guys will be gone? And then your square root 3, positive square root 3, when you add to negative square root 3 becomes 0. This and this will be cancelled off. Okay, and finally, so can you see that some of these numbers, no, you can actually cancel them off because they will add up to get 0. So finally, what you get here, okay, will be just negative 1 plus square root 9. And that gives you negative 1 plus 3. That gives you 2. Okay, isn't it interesting? So this is how you can actually solve 19 part 2. Okay, let's erase it. Okay, now it looks nicer. Alright.